What's up, Human Physics class? This is section 10.3. Our focus today is going to be on accessory organs of the digestive system. Basically what this means is we are not looking at anything inside of this alimentary canal where our food moves through. We're looking at things that assist the digestive system. So let's get some notes down. Learning objectives today. So by the end of this notes section, you should have an understanding of the accessory organs and how they assist with digestive processes, especially in the small intestine. And we're going to identify those major organs and glands that assist this process. And we're going to look at what enzymes are responsible for breaking down our food, as well as how this system coexists with other systems in the body. So to start things off, we're going to focus on the pancreas. Pancreas, just to give you an idea of where it is located behind the stomach and extends laterally, which means that it moves left to right in the body from the duodenum, which is a section of the small intestine, which we haven't really learned about yet, but you will see toward the spleen. Basically, the duodenum is the first section of small intestine that exits the stomach. What is its job? It's an accessory organ, and it's going to secrete digestive enzymes as well as buffers that help neutralize chyme. Now, chyme is something that leaves the stomach, and we know the stomach is a very, very acidic environment. So we use buffers to really help bring that acidity down. If I haven't mentioned it yet in the videos, I believe I may have, but the stomach has about a pH of about 1, so you're going to want to definitely find a way to neutralize that. Next thing, it secretes insulin as well as glucagon. So the pancreas really maintains your blood sugar. And to do that, when you eat something sweet, anything with sugar, your body secretes insulin, which helps break it down. If you are ever low on blood sugar, you will actually release some glucagon, which is glucose-based, into the blood. Basically, what I'm trying to say is your blood is very similar to your body temperature. There's an amount of sugar we should have in our blood, and our pancreas helps maintain that. Now, it also is going to carry out any secretions into the small intestine and will align with the common bile duct from both the liver and the gallbladder. So you will see various juices that we'll talk about that the pancreas will be secreting. So this image gives you a little idea of where the pancreas is located and how it works with everything. So here's the pancreas in yellow here. They have it set as a head, a body, and a tail. I don't really care that you know this, but basically all these juices are going to release into the small intestine. So actually back here, this is the stomach, and this is the portion of the small intestine that's going to work its way through. This minor opening here is something called the pyloric sphincter, which basically allows food to leave the stomach and enter the duodenum, which is the small intestine. Notice that it does work with the common bile duct, which is a tube that's going to feed up to the gallbladder, and as well as, if you would have an image here, this would be the liver up here. Okay, but this will at least give you an idea of where all these pancreatic juices flow into the small intestine and then begin to digest things into the first portion of our small intestine. So what are the kind of intended targets, so to speak, for pancreatic secretions? Well, off to the right here, the pancreas is considered both an exocrine and an endocrine gland. So exocrine means to release something. Pancreas has a lot of things to help break down our foods. Number one, it has carbohydrases. So remember, anything that ends in an ASCE is considered an enzyme, which is to break things down. So that'll break down sugars and starches. Lipases will break down lipids, which is basically fat. Nucleases will break down nucleic acids. And proteases will break down proteins. So you can kind of see how all these are affecting various things that we eat. So the pancreas has a really, really important job. Now, why do we want to break all this stuff down? Well, the more you break it down, the closer we get to those essential nutrients. A lot of time, the problem that we have with our bodies and the efficiency is that we cannot effectively take up everything. So when you maybe heard when you're younger to chew your food, it's not only because you want to keep your mouth shut and not have your food going everywhere, but you want to basically break that down into the smallest possible thing you can. So these are going to do this at a chemical basis, whereas if you're chewing your food, that would be more at a mechanical basis. All right, so let's talk a little bit about this blood sugar thing. So not only do we have all these enzymes, we also have the ability to regulate blood sugar. Now, insulin is required to help regulate that blood sugar, and as well as glucagon. I really should have glucagon here as well. They both kind of do that at the same time. But just to give you an idea of what these things mean, if you were hypoglycemic, hypo meaning below, that means you have low blood sugar and a high insulin level, which means that you're going to have to find a way to regulate that. If you're hyperglycemic, you have high blood sugar and low insulin. So your pancreas is constantly getting signals from the brain as well as the liver and various other things in the bloodstream just to make sure that we are getting a sufficient amount of glucagon versus insulin. So, what controls pancreatic secretions? Because on an average day, you can secrete about 1,000 milliliters of pancreatic juice. The big thing is it's regulated by hormones from the duodenum. So basically, when you get food into your duodenum, then those hormones are secreted, and it's kind of a positive feedback thing. So the more hormones that are there, the more secretions that you'll have, and you will start to break down those things. So as mentioned before, here are some other of the enzymes. Some we've talked about, some we haven't, but at least you get an idea that its job is to send signals to release those. Again, a reminder that we have buffers in there to neutralize any acidity or alkalinity to make sure that our pH level is good as well. So, one disease. I know we're going to go through diseases as a project base, but I just want to throw a couple in here. Pancreatitis. Anytime you have an itis, that means inflammation. So inflammation of the pancreas due to the enzymes that are attacking it is essentially what it's happening here. And these enzymes are not properly released in the small intestine, or they are released in really large levels. So it can be a hormone issue, but as you can see, you look at a pancreas here, it's swollen. It's inflamed, it's not secreting properly, and what ends up happening is it puts a lot of pressure on other parts of your body. And it can affect other parts of the body, and it won't allow your digestive system to work properly. So, moving on. Pancreas is done. Let's move on to the liver. Liver is a large organ. It weighs about 1.5 kilograms or about 3.3 pounds. We call it the largest visceral organ. Remember, visceral means internal. Kind of a very firm reddish, and it's reddish-brown in color, so it's a pretty big organ. It also contains the gallbladder. Gallbladder sits just below the right lobe of the liver, and it has a job which we'll talk about a little bit later. So the liver is responsible for filtering blood and basically returning it back to the systemic circuit. So as blood is moving through your body, your liver acts as a filter, very much as an oil filter or an air filter in a car, maybe the filter in your furnace, or even a filter in like a Brita water pitcher. It's doing the same thing. It's trying to remove toxins from that and make it cleaner. It also helps in regulating the metabolism. So, making sure that you're secreting hormones properly and balancing the blood sugar as well. And then a major thing that it does is it secretes bile. Bile is made up basically of lipid breakers, which basically help break down lipids and help us digest fats. We do not digest fats very well. Fats are extremely hydrophobic, and we are a very hydrophilic system. We have a lot of water in us. So, but it's basically made up of water, ions, bilirubin, cholesterol, and lipids, and it's going to dilute and help buffer acids. But the main key is it's an emulsifier. To give you an example of emulsifier that you use, soap is an emulsifier, which means that it helps absorb and break down fats. So if you've ever maybe made your own hamburgers, you know what I mean, and you're kind of kneading that ground beef, and you kind of get that fat, that solidified fat in your hand, you try washing your hands off with just water, it's not going to come off. So you need an emulsifier, and that's what soap would be. So your liver secretes bile, which emulsifies and really breaks down those fats. Because as you can see, here's a lipid. It's very strongly bonded, okay? So here's an example of an unhealthy liver due to things like alcohol abuse or something of that nature. But this is something called cirrhosis, which is very common. And basically what happens is we have a really a big issue with blood flow and not allowing the liver to digest properly. So you kind of get these little polyps all along the liver just from being over-toxified. And that could be a major issue and really affect how your liver functions. Definitely can die from that. All right, last but not least, the last accessory organ that we're going to talk about is the gallbladder. Yes, you can live without it. It is located underneath the liver, and basically what it does is it's a muscular sac that stores concentrated bile. This is the potent stuff. So stuff that if you just went to cops, haha, like I just did, here it's Friday afternoon, my gallbladder is working overtime. Essentially what it's going through right now is breaking down all of those fats and allowing your body to digest them better. So it can be removed, but that basically means that you are putting all bile storage and release on the liver, which is tough to do because the liver does not contain very concentrated bile. So what ends up happening is you really struggle breaking down anything that's high fat. You'll probably end up getting a lot of diarrhea, bloating, upset stomach, something of that nature, but you can kind of have the idea. So a gallbladder is needed, especially if you're hitting up that McDonald's a lot. So, just a little review. Hopefully, after watching this short video clip, you get an idea of what are accessory organs, how do they assist with digestive processes like breaking down carbohydrates, proteins, lipids, nucleic acids, and all those enzymes that do that. Also getting an idea of what bile is used for. It's an emulsifier. It's going to help us break down our fats. And really understand that all of these accessory organs work with one part of the body, and that's that small intestine. So that first part, the duodenum, is responsible for where all these enzymes are being released into. And the big takeaway here is that we are really working a lot also with filtering our blood. So when I talk about how does the system coexist with other systems, we're really focusing on your circulatory system and how that works. So hope this has helped you guys. Make sure you get these note sections done. 10.4 is going to dive into a little bit more on the small and large intestine, really get an idea of how we absorb things, and go from there. So enjoy the rest of your day, and we will see you tomorrow.